All right, so let's try a quotient rule. So we will take what is the derivative with respect to x of x plus 1 divided by x minus 1. So what is the derivative of this quotient? So as before, we'll take the differential first. And really, one of the nice features of taking differentials, I don't have to keep writing this d dx. So not only will it help you in the future for other projects, but it also is easier on your your pencil letter, however you want to think it. So d of x plus 1 divided by x minus 1. The quotient rule, so let's scroll back up and remind ourselves what that says. Says that I will take the denominator and multiply it by the differential of the numerator. I'll subtract the product of the numerator with the differential of the denominator and divide that whole thing by v squared. So again, that's low d high minus high d low all over low squared. So keeping that in mind, recognizing that really in this format, the top, the numerator is this is our u, and this is our v in that differential rule. So then this is just equal to low x minus 1 d high x plus 1 minus high x plus 1 times our d low x minus 1, and then the whole expression is divided by the bottom, the numerator, the low squared. So writing out, this is low d high minus high d low all over low squared. And so that's the mnemonic. So going through this differential, again, we know the sum and difference rule. So the differential here, this d, will distribute across addition and subtraction. So we'll slide it on over there. Same with this d. It'll stick to the dx, and we'll get a d1. So this whole term, the top becomes x minus 1 times dx plus d1 minus x plus 1 times dx minus d of 1 all over the numerator squared, or denominator squared. Now, d1, as we know, is 0. That's the differential of a constant, so it zeroes out. d1 here zeroes out. So I end up with, this is all equal to x minus 1 dx minus x plus 1 dx all over x minus 1 squared. And we could clean this up a little bit. We've got a positive, when we distribute through, we'll have a positive x dx, and notice we're going to have a negative, we'll be subtracting a negative x dx. And here we'll have a negative 1 dx, and we'll also have another negative 1 dx. So the numerator algebraically simplifies to just simply negative 2 dx. And the denominator is x minus 1 squared. So that's what the differential of x plus 1, x minus 1 is. So if I want to know the differential with respect to dx, or the derivative is, then we have that the derivative with respect to x of x plus 1 over x minus 1, well, we computed the differential of this term already. It's negative 2 dx over x minus 1 squared. So if we divide through by a dx, it'll cancel with that. And so the answer is negative 2 all over x minus 1 quantity squared. Let's take the derivative of maybe something a little bit more complex here. Let's say y is equal to, let's say 2x plus 1 quantity squared times x squared plus 1 quantity cubed. So I take the differential. We're going to have a lot going on. We've got a product rule. When we take the product rule, you'll see hopefully that we're going to have exponent rule, power rule, and sum and difference. Almost everything's here. So as in all the other examples, we'll start with the differential. So dy is equal to the differential of 2x plus 1 squared times x squared plus 1 cubed. And first off, I've got the product rule. So just being careful that we recognize that this whole thing is the first term in our product. So that's our u. And this second term, the whole expression, is our v. So the trick or the skill that you need to develop is recognizing which are our pieces to apply to the rule. So this is equal to v du, so x squared plus 1 cubed, that's our entire v, times the differential of 2x plus 1 squared plus, now our u term, 2x plus 1 squared times the differential of x squared plus 1 cubed. And so that's done. Now here I have the exponent rule, the power rule. This whole thing is my base. So that's my u now here. So the 2 will come down, become the coefficient, and decrease by 1. Here in this example, x squared plus 1 is my u for my power rule. So in either case, I apply the power rule, and I get that this is equal to x squared plus 1 cubed times, so this is 2, the exponent comes down, becomes my coefficient. My u is 2x plus 1. It's raised to the first power, I reduce by 1, and I still have to take the differential of u. Then this is added to 2x plus 1 squared. Times, and my power rule, the 3 comes down as my coefficient, x squared plus 1 squared, because my power comes down by 1, times the differential of x squared plus 1. All right, so I've dealt with the power rule there. I still have some more differentials to compute. This d will slide through across addition. And I'm also going to kind of skip a step. It also, as we know, will slide right past the 2. And here, the differential will slide past there, and we get that this now is equal to x squared plus 1 cubed. I'm going to slide this 2 in front, just to be neat, times 2x plus 1. And then in there we get times 2 dx. And I'll write it again, but I'll probably eventually stop writing this because we should know that the differential of a constant is 0. So anyways, then here I'm going to write, so it's plus, and again I'll bring this 3 in front just to make it neat, 2x plus 1 quantity squared times x squared plus 1 quantity squared. And this becomes just d of x squared. Where'd the d1 go? Well, it's 0. And so finally, to wrap this up, one more step. This dx here is completely dealt with. We've got down to dx, so we know there's nothing more to do. But here we've got a dx squared, so one more differential to finish this all up. And this is equal to, writing this all out, so the 2 comes up there. So 2 times 2 is 4. So I get a 4 x squared plus 1 quantity cubed times 2x plus 1 dx plus, so when I take the differential here, I'm going to get 2x dx. So I'm just going to quickly do that step. I think we've done the power rule enough times. Right, this 2 comes down, and it'll become the coefficient and reduced by 1. And so that 2 times the 3 that's already there, right? When this 2 comes down, I can multiply by this 3, so I get a 6 times 2x plus 1 quantity squared times x squared plus 1 quantity squared dx. All right, so we've taken all our differentials. Remember what we're doing, we've got dy, so maybe I can write it out. So dy is equal to 4x squared plus 1 cubed times 2x plus 1 dx plus 6 2x plus 1 squared times x squared plus 1 squared dx. So then if I want to know what dy dx is, the derivative, I just simply divide the differential by x. And when I do that, I have got a dx here, and so it will be canceled out, and I've got a dx here, and so it will be canceled out. So our final answer, dy dx, is 4 times x squared plus 1 quantity cubed times 2x plus 1 plus 6 times 2x plus 1 quantity squared times x squared plus 1 quantity squared.